Good morning, everyone. We're going to get started in about 1 to 2 minutes and let everyone join. Looks like we have about 14 people here, so we'll just keep it open for a couple more minutes and we'll get started. All right, thanks again for everyone for joining. We're going to go ahead and get started. My name's Fred Seiler. If you've attended any of the other presentations, I've been leading them. So thanks again for joining us and welcome to everyone that's new. Today we're going to be talking about combined heat and power, and we have two great speakers to present on that. So a quick agenda. I did introductions. My name's Fred, and we'll talk about our speakers here in a minute. We'll touch on our sponsors, talk about some additional educational opportunities that we're offering here in Michigan. And then we have a presentation on CHP, combined heat and power, not vertical indoor farming. Sorry about that. Looks like this slide didn't get updated. And then we have a Q&A session. So again, all of our attendees are on mute, and there's a chat bar to the side. So throughout the presentation, if you have any questions, feel free to put them in there. And then we have a recording of this webinar at the on the website. We usually post it about same day or day after. So be sure to check that out if you have any questions. Real quick, we want to thank our sponsors. We have Consumers Energy, Semco's Energy Waste Reduction Program, Efficiency United, UPCO, and DTE. And again, thank you to all these sponsors. Typically, we do this in person, one in the Lower Peninsula, one in the Upper Peninsula, and it's a big affair. And this year, obviously, we had to make some changes, and so we're obviously very grateful to all of our sponsors for continuing their support of the program and this educational opportunity for CNI folks in Michigan. So we have this other webinar that is being run by Mark Jewell. Mark Jewell is a well-known energy expert in the field, and we're offering a no cost to registered trade allies with the Semco's Energy Waste Reduction Program and/or Efficiency United. So if you're a registered trade ally with either of those programs, be sure to check out this opportunity. It's a 6-part webinar series. It got started a couple weeks back. We're on the third session, but you're welcome to join anytime you want. It's every Thursday, 1:30 to 3 p.m. And our next session is on October 22nd, and the topic is replacing reactive with proactive. So be sure to check that out. It's you can register at sellingenergy.com/Michigan. And if you do have any questions about it, again, we do have that chat bar on our website, so feel free to ask any questions. Again, this is just a nice little thing that we're doing for anybody that attends at least 2 webinars. You'll get a free grill kit and then some promo items from our sponsors and just some more information about some of the topics. The kits will be mailed out in mid-December, so be sure to register for at least 2 webinars. All right, and with that, I'm going to kick it off to Zaheer and Sean. Zaheer and Sean are here at Clear Result. Their topic today is combined heat and power, and they have a lot of experience with the topic and working through applications and guiding customers through that journey of getting started with the program. So, really happy to have them here, and I'll hand it off to them.
Great. Thanks, Fred. Good morning, everyone. Hope everyone's had a great day so far. We can go to the next slide. So today, Zaheer and I, sorry, this is Sean speaking. Today, Zaheer and I are going to go through combined heat and power systems and do our best to try and demystify them. And as they can sometimes be seen as relatively complex, really they're pretty simple, but the projects themselves can get complicated, and we'll get into that. So we're just going to start with fundamentals, kind of go through potential benefits and risks, and then we'll go through some case studies so you can see how these things can look in application. We'll be using some diagrams to kind of show all the different interconnected systems, and we'll have time for questions at the end for sure. We'll have time left at the end, and obviously you can type anything in the chat if you feel like you don't want to wait till the end. We might be able to get to it midway. Great, thanks, Fred. So at its core, CHP systems are combined heat and power systems. It's an energy efficient technology that combines electricity generation and the capturing of heat that would otherwise be wasted to provide useful thermal energy. That's the heat that's produced as part of the electricity generation process. Typically, you're fueling it with natural gas from a grid or some other on-site waste byproduct. And that list is almost endless. There's lots of different things that you can burn, essentially, to produce electricity and output heat. So the thermal energy can be in the form of steam or hot water, and you can use it for space heating, for cooling, domestic hot water production, and for various industrial processes. We will also get to it, but you can have steam going into these systems as well as having it as an output. And we also just put some definitions on the side for some common acronyms that you see in this industry. We're not going to go these. We're kind of going to touch on these, but mostly we just want to have these on hand for you guys. And if you're looking through this later, wondering, if you're looking through material or brochures from other places, so you understand kind of what they're talking about. Great, we can go to the next one. So at the top, there's really all CHP systems. You have fuel going into a prime mover, and it's outputting heat and electricity. It's really that simple. As a result, you can mix and match with lots of different systems. So fuel going in, natural gas is very common. But then, as we said, there's many different waste gas types that can go in: biogas, landfill gas, incinerator waste gas, process waste gas, and in the process, we're talking about stuff like coke oven gas, and things like that. Lots of there's different kinds of gases produced as part of steel production, for example, that can go into this kind of stuff. And there's always ways people are coming up with different ways to kind of use waste products. As well, if you can create steam, you can potentially drive a turbine as well if it's a high enough grade steam. So that means it doesn't necessarily have to be a standard gas. It can be some other way to create heat if you can make it hot enough to produce high grade steam. So of the prime movers, lots of different types. You're probably most familiar with something like an internal combustion engine, something like you have in your car, or if you've ever seen a like very common like a diesel on-site generator for something like backup power for an office building or a condominium. If you designed to run 24 hours, those are often internal combustion engines, really, really big ones. They produce low-grade heat. And when we say low-grade heat, we're talking about temperatures below 400 degrees Fahrenheit. And that you can use heat of that temperature for things like space heating, domestic hot water production, or low pressure steam, if you have any processes that use low pressure steam. They're common in hospitals, academic institutions, and recreational facilities. We also got gas turbines and steam turbines. They're similar in where you find them, but gas turbines, typically that's where high grade heat is required. So medium and high pressure steam. And these are very common in industrial facilities. High grade heat is above 1200 degrees Fahrenheit, if you guys are wondering. And steam turbines are very similar application, but if you, for example, are already producing high pressure steam on site, you already have essentially the fuel for a steam turbine. And then you can still use the output steam that's usually in the low grade range. You can still use that for production or processes on site. So that can often be very useful. depending on the facility you have. Or if you decided you were going to upgrade your boilers and you want to produce steam anyway, again, there's lots of different things you can do with those, but generally industrial facilities. You've also got microturbines. They're typically less than 100 kilowatts is what we're talking about. You can find these in residential buildings where the demand for domestic hot water is pretty constant or at least steady. If it's spiked, there's at least always some use. And you can also use them modularly. So if you are knowing you're starting a facility that you know will be expanding, but you don't want to buy equipment for the future size right away, you can use microturbines in series or in parallel to as you need. So also fuel cells. So fuel cells are not common at all. We're from Ontario. We've only really seen a few of these through the energy incentive programs that we operate in. It's not common at all, but there is a growing hydrogen economy, and we may see something like this make more sense in the future. As well as I think you can get natural gas fuel cells, lots of different kind of fuel cells. So that's a very interesting area. It's growing, but not common. Any questions so far? And it's fine if you think of something else. We can get to it later. Thanks, Frederick. So potential benefits and risks, like anything, you've got both. So benefits, financial. I think most of us are concerned with this. You've got a overall reduction in electricity spending in general, and so that helps this be a hedge against electricity rates. So typically, you're going to find that energy sourced from natural gas is going to be cheaper than from electricity. There are places where that's not true, but generally that's what you're going to find. You've also got some benefits in terms of if you go into a power purchase agreement, for example, with a third party, you don't have the upfront costs or upfront cash to be able to afford these things right away. There's lots of providers that are happy to front those for you and then essentially sell you the electricity back over time, and often at a rate competitive to what you otherwise would have to pay from the grid. Yeah, that's kind of those are the main ones. Really, what it all comes down to is saving money for a lot of folks. And you can see in many facilities you can have very healthy payback rates for these, but again, it's very case by case. It's going to depend on what you're doing in your facility. Increased reliability, so redundancy during emergency periods, peak periods where you may be it may be very expensive to use electricity. That's very common in different areas that we work in. Or like even just brownouts, or if you need like to have very critical facilities where you need to know you have uninterrupted power, this is something that can work really well with that as well. Not just there's lots of ways in which you can use something like this, and you may be required by code to have a backup generator, a traditional backup generator, but there's nothing wrong with having redundancy for that equipment as well. But if it's possible, you may be able to replace your backup generator with something like this, depending on the rules where you are. Environmental, so yeah, you can get, judging from the little bit of work we did and understanding the Michigan's mix of electricity generation, the ways in which electricity is made, I think it's likely that you would see a overall reduction in greenhouse gases if you went with even just a 100% natural gas fueled CHP system, since I think there is still coal production in Michigan. So that is something that you could be really valuable to stakeholders of this project that you may be considering. The natural gas is definitely not as bad as coal when it comes to greenhouse gases, as well as if you're producing something like methane on site, and we're talking about a waste energy recovery project, that's, often you're not allowed to release methane unburnt into the atmosphere, right? So that's just an extremely potent greenhouse gas, and so you'll have to flare it usually, right? But instead, you can turn something like that into fuel or a cash flow, essentially, right? You're going to be turning that into money with something like this. And yeah, fuel to electricity efficiency compared to the grid, again, depending on how close you are to power generating facilities, you'll be able to create electricity with a better fuel to electricity efficiency than the grid average, at least most of the time. If we're looking at the average grid across the board, you're likely going to be able to achieve better than grid average efficiencies. Now, For that to truly be possible, you're probably going to have to be able to have a system where you're running your CHP system almost all year round. It's tough to meet those sort of efficiencies if you're only doing it here and there. It'll also, frankly, be hard to make it cost efficient if you're doing it here and there. So you're going to be looking for something where you're running it most of the year. Risks. So things can be complicated. And so as much as the technology is simple, it gets complicated when you start trying to plug it into all of your existing systems. Some of these systems might be ones you haven't touched in a while. And so for that reason, it can get complicated and timelines can be hard to nail down. If you're working with someone like an ESCO, whereas often these conversations start, they're not familiar with their systems right away either. So they can talk about timelines, but it's always going to be an approximation. And yeah, that's something you'll really need to consider. Local authorities, they're often not going to be a barrier to you, but they will need to understand what you're doing, and they're going to want to know, like, how much electricity are you producing, how much will you not be buying anymore, in order to be able to plan their grid out. So there's that. These are not full barriers. They just might help. They might slow you down, part of the process. You might also have capacity constraints related to that. So if the local grid is not very robust, and if this might be compared to the rest of your surrounding facilities, you're producing a lot of electricity compared to the grid. They may have some concerns there, but again, often these are just conversations you need to have, and you need to keep your authorities in the loop. And usually, there should be no issue as long as you're planning for it. Like most things, I suppose. We can go to the next slide there, Frederick. Okay. And now I'm going to hand it off to Zaheer, who's got a lot of experience with these systems as well. He's going to walk you through some case studies that might help give you a better sense of what these things really look like and how they play out.
Thank you very much, Sean. Good morning, everybody. I'm going to be presenting two CHP case studies. The one that you're seeing here on the screen, this is a CHP system installation in a hospital. The prime mover for this CHP system is a reciprocating engine. This CHP system is fueled entirely by natural gas. As you can see, there's electricity generation. There are two sources of heat in this CHP system. One is from your engine cooling system. When I say engine cooling system, I mean, heat from your jacket, your engine jacket, heat from your lube oil, and, your first stage intercooler. You can also extract heat from the exhaust gas, that leaves the engine. So in this CHP system, heat is recovered from the engine cooling system to produce hot water. This hot water is supplied to the space heating loop in the heating season. In the cooling season, this same hot water can be used by an absorption chiller, for chill water production for space cooling. Heat recovered from the the exhaust gas, which has a fair amount of high-grade heat, can be used for low-pressure steam production. Hospitals use steam for sterilization, and they also use them for other purposes. The key benefits to having this kind of a CHP system in a hospital: you have a very reliable source of electricity. As you know, hospitals have essential services. They require a constant supply of electricity. If the grid goes down, the CHP system can serve as a reliable source of electricity. Also, when you have the CHP system, you don't have to, you don't have to run your diesel generator. Kind of makes it redundant. Because you're using an absorption chiller for chill water production, you don't have to run your, your electrical chillers as much. So, you can expect a reduction in electricity consumption of your electrical chillers. And, there's also, reduction in boiler maintenance costs, because this CHP system is, supplying heat, right? So, it's displacing heat from the boilers. Boilers will consume less natural gas, and they're also going to require less maintenance. Can I get the next slide, please? Okay. This CHP system is an installation in a wastewater treatment plant. This CHP system is fueled entirely by biogas, which is a byproduct of the wastewater treatment process. This biogas is typically flared to the atmosphere. There are some uses within the facility, like in boilers, but where you have excess biogas, it gets flared to the atmosphere. This CHP system actually presents an opportunity for the facility to consume, this waste byproduct and convert that to electricity. As you can see in the diagram, the prime mover for this CHP system is also a reciprocating engine. You've got heat recovery from your engine cooling system, and also your exhaust gas in one loop, using that to produce hot water. This hot water is fed into the digesters, for temperature control. And of course, you're also generating electricity. The key benefits to having this kind of a CHP system is you're using your waste byproduct, that's being generated in the facility, and you're converting that to electricity. You have, reduced reliance on fossil fuel, because this CHP system is fueled entirely by biogas. You're not consuming any natural gas. There's no fuel transportation requirements specific, to this project, because, you're consuming biogas, which is being produced on site. You've also got a reduction in greenhouse gas emissions, as a result of this project. And that's it from my end. Thank you very much.
Great, thank you both Zaheer and Sean for that great presentation. If you have any questions, feel free to put them in the side chat bar right now. We'll be happy to ask those. I guess one of the things that stuck out to me, Sean, during your part was the local authority approval process. Can you, provide some more context on that, or what that looks like, or if you have any examples?
Yeah. I mean, so I can speak to our experience in Ontario. So we have, I won't get too into details because it's weirdly complex and doesn't necessarily translate fully, but you have your regulator view of things and you have your utility view of things. The regulator is going to have probably some specific criteria about the types of systems that are allowed to generate electricity on the grid. They may have, they may draw a line between quote unquote behind the meter, or which is usually what we're talking about here. So it's, the meter would see the drop or increase in electricity. But they may have like technical requirements, like making sure that nothing goes into the grid. And then you also have the utility themselves, which, or whoever, either sometimes the regulator, sometimes it's, I guess, the utility designing the grid and monitoring the power production on the grid, and having to worry about the complex interactions of generators and consumers, and knowing that there might be someone producing power somewhere on that grid in that physical location. That's something they need to sort of plan around. So that's their mindset. And so what it really means is, when, for us, these systems come to us through an incentive program, and so you're often interacting with one or both of these stakeholders as part of that program anyway. And so part of that is that whole process. If you want incentive, you have to go through a capacity screening kind of criteria. That's what they call it. And it's very rare that there's an issue there, but they need to always check. And sometimes that process can be a few weeks, and sometimes that process can be many months or more, depending on what's going on. I've seen, for example, someone wanted to go 100% CHP for a greenhouse expansion. I know there's lots of greenhouses in Michigan as well, but it made things complicated because the utility was planning to expand their grid out into the same region with the assumption that they'd be able to get money from the new greenhouses that are going up, right? So if the greenhouse says, no, I'm not going to be giving you any money because I don't need you, that makes things complicated. Right? So that's maybe a worst case scenario, and ultimately, that's going to come down to negotiating with the utility on larger issues. But most of the time, it's just a few boxes you need to check and have your information on hand. So yeah, I wouldn't be worried about it, but the sooner you get someone engaged, I think you really just pick up the phone and call your utility. You say, hey, this is what I'm going to do. Can I talk to your technical folks, or what do I need to do to make this go as smooth as possible? Usually utilities are very focused on their large customers, and usually it's their largest customers who are interested in these systems. So yeah, just start talking to people. That's my advice.
Great, thank you. We have a question from Ty Weiss. He says, in our area of Kalamazoo County and in other locations in Michigan, there's a program called PACE, which is the Property Assessed Clean Energy Program. And it's where energy efficiency projects can be funded by a property tax assessment. The project must meet defined efficiency thresholds. And so the question is have you implemented a CHP project using this kind of funding mechanism, or like, do you have any knowledge of how some of these projects are funded?
So in Ontario, we haven't really implemented that kind of funding. I think it's a really powerful tool. I'm a little disappointed we haven't done something like that. I'm going to assume. I mean, I've only heard of these systems as applied to like residential type applications where you're putting solar panels on your roof and things like that. If they do have that for larger commercial type buildings, I think I would not see that as an issue. And I think, again, because you should be able to make the argument that this is a better than grid greenhouse gas sort of impact, you might be able to make this qualify. It would be, you'd have to try and find the people who are going to decide whether you're adhering to the rule, like the letter of the law versus the intent of the law, right? Like this wouldn't necessarily be an obvious renewable energy type project, but that doesn't mean it isn't. Especially if you're talking about something like waste energy, that definitely would be something that's considered renewable. So I think your biggest hurdle will just be finding the right person to talk to. The sort of normal rank and file folks that are administering a program like that are not going to be able to necessarily help you. They may be able to help you get in touch with somebody, but I think it is worth engaging with those folks to try and make something like this work. Yeah, but it wouldn't necessarily be a super easy one. I don't think they're going to have that up front. Like, oh yeah, no problem. We have everything spelled out for CHP Systems. I think you'd have to actually kind of you'd have to do a little bit of work with them and yeah, push those conversations higher up the ladder. I think would probably be what you have to do. Does that help?
Yeah, I think so. Ty responded and said that PACE is available for commercial or industrial projects.
Okay,
so
great.
Yeah, great.
Industrial, I think, would actually be an even better one if they're making it available for industrial, essentially because these are often so deeply tied to production. Yeah, I think that's a really good candidate for something like that.
Great, thank you. So it doesn't look like we have any other questions, and we're coming up on time. So thank you again, everyone, for coming today. If you do have any more questions, make sure to go to the website. You can drop a chat into that chat feature, and we'll get that information to Zaheer and Sean and get you a response. So feel free to do that. Next week we have operation and maintenance strategies with Claire Hetzemer. That's again on October 27th at 10 a.m. So make sure to register for that. You should be receiving an email, and a recording of this presentation will be up on the website within 24 hours. Thanks again, everybody. Have a good rest of your day.
Thank you.
Thanks.